Welcome back to Mr. Vaughn's classroom, where math is made easy. Before we get started on the video, I'd like to ask you to please hit the subscribe button, give this video a thumbs up, and engage with a comment below. Today we're looking at Unit 1, Constructions and Rigid Transformations. This is Lesson 17, Working with Rigid Transformations. The learning goal for this lesson is to compare transformed figures. We have one learning target. When we get done with the practice problems, we'll come back and review this learning target to ensure you learn everything you need to from this lesson to be prepared moving on to future lessons. So the learning target for today's lesson says that you can describe a transformation that takes given points to another set of points. So they're going to give us an original, they're going to give us an image, and we're going to need to describe how we transformed the original to create the image. We have several glossary terms for this lesson. Assertion, we've talked about previously. This is when you make a statement that you believe to be true, but you have not yet gone through the steps of actually proving it true mathematically. Next, we have congruent. One figure is called congruent to another figure if there is a sequence of translations, rotations, and reflections that take the first figure onto the second. So when you do these rigid transformations, what happens is that you move it, you orient it differently, but you do not make it any bigger, you do not make it any smaller, so your side lengths stay the same and your angles stay the same. Next, we have directed line segment. This is a line segment with an arrow at one end specifying direction. So rather than simply having line segment AB, we now know that this line segment AB goes from point A to point B because of the arrow showing the direction. Next, we have image. When we do transformations, such as the one on the right side of the screen, we would consider the original triangle to be ABC down in the bottom left. And then as we translate it up and right, we create the image triangle of A prime, B prime, C prime. So the ones that we start with are the originals. The ones that we create through the transformations, that one is the image. Line of symmetry. A line of symmetry for a figure is a line such that reflection across the line takes the figure onto itself. The figure shows two lines of symmetry for a regular hexagon and two lines of symmetry for the letter I. So in the first one, we can see that if we folded that from left to right, the image would go right onto itself. In the middle, if we folded that diagonally along the line, then both sides would line up. And with the I, we could fold it top down, we could fold it left and right, but either way, we would take the image onto itself. Next, we have reflection. A reflection is defined using a line. In this case, that would be line M. It takes a point to another point that is the same distance from the given line, is on the other side of the given line, and so that the segment from the original point to the image is perpendicular to the given line. So in this example, line M is going to be that perpendicular bisector. So if we were to fold A over line M, we would create A prime. Next, we have reflection symmetry. A figure has reflection symmetry if there is a reflection that takes the figure to itself. So in this case, they give us an X. So instead of reflecting the entire X across a line of reflection and creating an image of the X on the other side, what we're talking about with a reflection symmetry is that we're going to take the shape onto itself. So we could do this by reflecting left and right. The two lines on the left would fold over and be right on top of the two lines on the right. Or we could do it up and down, and the V shape on the top would then fold down onto the A shape at the bottom. Rigid transformation. A rigid transformation is a translation, rotation, or reflection. We sometimes also use the term to refer to a sequence of these. So in the image to the right, we go from A to B by translating down and right. We transform from B to C by rotating clockwise, and we transform from C to D by reflecting across the line of reflection, which in this case would be the hypotenuse of the triangles. Next, we have rotation. A rotation has a center and a directed angle. It takes a point to another point on the circle through the original point with the given center. The two radii in the original point and the image make the given angle. So on the left, the point of rotation is O. P is the original. It rotates counterclockwise t degrees and creates the image P prime. On the right side, we have quadrilateral. ABCD is the original. It rotates 120 degrees counterclockwise, creating the image quadrilateral, which is A prime, B prime, C prime, D. So D is that center point that the other 3 points are rotating around. Rotation symmetry. A figure has rotation symmetry if there is a rotation that takes the figure onto itself. We don't count rotations using angles such as 0 degrees and 360 degrees or any other multiple of 360 degrees because these leave every point on the figure where it started. So we don't want to do a complete rotation, otherwise that top left point would stay right there in that top left point. But doing a rotation of 60 degrees would rotate the top left corner over to the top right corner. Now that point is not in the same spot, but we would still have the exact same shape of a regular hexagon. So unless we had the points labeled, we wouldn't even notice the difference. Symmetry. A figure has symmetry if there is a rigid transformation which takes it onto itself, not counting a transformation that leaves every point where it is. So this means that if I could do a translation, a rotation, or a reflection, something like that X, where I can take the left half and translate it over on top of the right half and have it line up exactly, that is when we would say that a figure has symmetry. Theorem. This is where we take that assertion that we talked about at the beginning of the glossary terms. Then we take that assertion and we prove it true mathematically. Once we have taken that extra step of proving it, then it becomes a theorem. Translation. A translation is defined using a directed line segment. It takes a point to another point so that the directed line segment from the original point to the image is parallel to the given line segment and has the same length and direction. So if we look at this, we have directed line segment T. Then we can do a translation to go from point A to point A prime, and now it is parallel to that line segment T, and they are both directed line segments because of the arrows on one end. Now that we're done with the introduction, let's go ahead and get started on the practice problems. Practice problem number 1. Quadrilateral ABCD is congruent to quadrilateral A prime, B prime, C prime, D prime. Describe a sequence of rigid motions that takes point A to A prime, B to B prime, C to C prime, and D to D prime. So, the first thing we can do is we can use a directed line segment to go from B to B prime. So once we've done this, this slides the entire quadrilateral on the left over so that it's pressed right up against A prime, B prime. Now what we can do is we can rotate 90 degrees clockwise. And once we've done that, let's specify 90 degrees clockwise with B prime as the center. So we're going to slide the one on the left over to the right until they touch each other and they share that center line. And then we're going to rotate that left shape clockwise 90 degrees with B prime as the center, and that will take the first quadrilateral and all four of its points and create the image on the right where A has now become A prime, B has now become B prime, C has now become C prime, and D has now become D prime. I hope this explanation makes sense to you, but if you do still have any questions, please leave a comment below. And now let's take a look at practice problem number 2. Practice problem number 2. Select all transformations that must take any point A to any point B. So that's the important thing. Notice the word must. Okay, those are always key words to look for. Things like must or always or never. These hard defining where they're saying every single time this must happen. So let's take a look at A. Rotation of 180 degrees around point A. Well, if I have point A and we have some point B, then if I rotate 180 degrees around A, then I'm just going to end up bringing B over to this side and getting B prime. That does not take A to B, so A would be incorrect. Choice B, rotation of 180 degrees around B. Well, this is going to look like the one we just did, only now B is in the center, and A is the point we're going to rotate around B, and I get A prime, but again, I did not take A to B. Therefore, option B is incorrect as well. Choice C, rotation of 180 degrees around the midpoint of segment AB. So let's make a segment AB, and we're going to identify the midpoint. So if this is A and this is B, and if I rotate 180 degrees around, then A is going to go to B. So therefore, C is correct. Option D, reflection across the line AB. Well, if I have AB and I have a line, if I reflect across this line, then neither of these points change. Anything on the top would go to the bottom, anything on the bottom would go to the top, but A stays exactly where it is, and B stays exactly where it is. So A does not go to B, so D is wrong. Option E, reflection across the perpendicular bisector of segment AB. So let's say we have AB and we have its segment. Now the perpendicular bisector is going to go right through the middle of that at a 90-degree angle. We can say that this is A and this is B. So if I reflect A across the perpendicular bisector, it will in fact go to B because they must be exactly the same distance from the perpendicular bisector by definition. So that means E is another correct choice. Option F, translation by the directed line segment AB. Well, if I have a directed line segment and it's AB, then that means I am taking A to B. So F is correct. Option G is the opposite. Translation by the directed line segment BA. So in this case, we would actually be taking B to A. And we wanted to take A to B. So G would be wrong. So this problem is just making sure you understand all three rigid transformations. We started out with 3 options for rotation, and C was the correct one. Then we had 2 options for reflections, and E was the correct one. And then we had 2 options for translations, and F was the correct one. I hope this makes sense to you, but if you have any questions, please feel free to leave a comment. Now let's go ahead and take a look at practice problem number 3. Practice problem number 3 is going to be the last practice problem in this lesson. Once we're done with it, we'll go back and review the learning target just to ensure you've learned everything you need to from this lesson so you're prepared moving forward into the next one. Triangle ABC, which is the blue triangle, is congruent to triangle A prime, B prime, C prime. That's the green one. That means they have the same side lengths and they have the same angles. They want us to describe a sequence of rigid motions that takes A to A prime, B to B prime, and C to C prime. So there's a couple ways you could do this, but generally the easiest way is to first use a directed line segment. So we're going to use a directed line segment to go from point A to point A prime. And that's going to slide this entire blue triangle to the right. So use a directed line segment, A prime, to translate the blue triangle to the right. Now, once we've done that translation to the right, we're going to rotate clockwise until point C moves to point C prime. So rotate clockwise around A prime until C becomes C prime. And once you've done those two rigid transformations, then the blue triangle ABC will line up perfectly and become the green triangle A prime, B prime, C prime. I hope this helps you out. I hope it's made sense to you. But if there are still any questions, please leave a comment below. Now, before we end the video, let's go back and review the learning target just to make sure you understand everything you need to from this lesson. That way you're set up for success moving in to the next one. So just to review the learning target for lesson 17, this one said, I can describe a transformation that takes given points to another set of given points. And the ones that we really concentrated on in this lesson, we did a lot of translating by a directed line segment, and we did a lot of rotation around a certain point, but we've also seen where we can reflect across a line of reflection. So just make sure you understand those three rigid transformations, how to use each of them, and how to describe what it is you're doing with those three. As long as you feel comfortable with that, you should be well prepared moving forward into the next lesson. If you still have any questions, please feel free to engage with a comment below. If you found this video helpful, please give it a thumbs up. If you want to continue seeing videos like this, in the bottom left of the screen, you should see another video in this series that YouTube is recommending. In the bottom right of the screen, you should see the subscribe button for the channel. It would really help me out if you would subscribe. You'll also get notifications as I add more videos in the future. Thank you for taking the time to watch this video. I look forward to seeing you in the next one.